Hello and welcome back. In the previous lecture, we have seen how to write a Dockerfile to build an image. In this lecture, we'll learn a little bit more about the Dockerfile syntax and some best practice to write Docker files. First of all, we'll take a look at how to chain run instructions. One thing to keep in mind is that each run command will execute the command on the top writable layer of the container, and then commit the container as a new image. And that new image is used for the next step in the Docker file. So each run instruction will create a new image layer. It's recommended to chain the run instructions in Dockerfile to reduce the number of image layers it creates. I'll show you how to do this in a second. Here, we modify the Docker file. Instead of having 3 instructions, we'll do apt-get update and apt-get install git, and Vim to aggregate those 3 instructions into one. Let's save the Docker file and rebuild the image. As you see, we have only 2 build steps instead of 4, which means it is only adding one more layer on top of the base image instead of 3. Another good practice when writing the run instructions is to store multiple line arguments alphanumerically. This will help you avoid duplication of packages and make the list much easier to update. Let's say we want to install Python package as well. We need to put Python between Git and Vim so that they are sorted alphanumerically. Now, we'll move on to the CMD instruction. CMD instruction specifies what command you want to run when the container starts up. If we don't specify CMD instruction in the Docker file, Docker will use the default command defined in the base image. In our case, it is Debian Jessie, and the default command is bash. Unlike the run instruction, the CMD instruction doesn't run when building the image. It only runs when the container starts up. You can specify the command in either exec form, which is preferred, or in shell form. Let's see this in action. We modify the Docker file. Add CMD instruction after the run instruction. Here we echo hello world. Let's rebuild the image. The build completes successfully. Now let's start a container from this image. Just copy the image ID here. See, it prints hello world. We can also overwrite the CMD instruction at runtime. When you do Docker run, you can specify a different command to run. Let's rerun the container from the image and overwrite the CMD instruction with echo hello Docker. See? This time it prints out hello Docker instead. The next topic we're going to talk about is Docker cache. You probably have already noticed last Docker build is much faster than the first build. That is because Docker cache. Each time Docker executes an instruction, it builds a new image layer. The next time, if the instruction doesn't change, Docker knows the image layer already exists, rather than building it again. Docker will simply reuse the existing layer. As you see, the last Docker build does not redo step 2. It just reuses the image built previously. This helps to make our build much faster. If you're building many containers, this can greatly reduce build time. However, if Docker cache is used too aggressively, it may cause issues. For example, say you have a Docker file like this. After building the image, all layers are in the Docker cache. Suppose you later modify apt-get install by adding extra package curl. Docker sees the first and second instruction are not changed and reuses cache from previous steps. Because the apt-get update is not run, you can potentially get an out-of-date version of git and curl. The solution is to chain the apt-get and apt-update command as a single instruction, so that whenever the apt-get command is modified, the whole instruction will rerun to ensure you get the latest version of the package. You can also tell Docker to invalidate cache by using the no cache flag when issuing the Docker build command. Next, let's talk about copy instruction. The copy instruction copies new files or directories from build context and adds them to the file system of the container. Let's see this in action. Here, we add abc.txt file in my current directory. Let's modify the Docker file. Remove the cmd instruction and add a copy instruction to copy the abc.txt file to the container. Then save the file. Just rebuild the image and run the container. Let's enter the source directory. See? We get our abc.txt file. There's another instruction which is very similar to copy. That is the add instruction. Those two instructions are quite similar. The difference is that add can do more magic. Add allows you to download a file from internet and copy to the container. Add also has the ability to automatically unpack compressed files. If the src argument is a local file in a recognized compression format, then it's unpacked at a specified test path in a container's file system. Generally speaking, copy is preferred. That's because it's more transparent than add. Copy only supports the basic copying of local files into the container. Copy is really just a stripped-down version of add. Ultimately, the rule is this: use copy, unless you're absolutely sure you need add. I hope you have enjoyed this lecture. I'll see you later.